This has been finished because this might take some minutes. Okay, now we've also got Java 8 installed. Let's figure out what's the case. We run java --version and we can see we are using Java 11 right now. To switch back to Java 8, we have to update those alternative config, and we can do this by sudo update alternatives --config, and then we provide Java. And here we can see we are using Java 11, but we can switch now to Java 8 because we have this now installed. I type in number 2, we can see this on the selection over here. And now we are using Java 8, and that's all. This is pretty easy, right? Let's figure this out. We can see this Java 8 has a different version parameter, which is super ridiculous, but okay. And now we can see, yes, we are using version 8. We also have to do this for the Java compiler. And therefore I go back to the command and I simply do this once again for Java C. I also provide the selection 2 over here. And now we also have this Java C instance updated to Java 8. Is it the same? Yes. Okay, now let's try running Gephi once again. And we can see, yes, Gephi is now working. Great. Please take care that you have switched your Java instance for now, and this might interfere with other tools. So after using Gephi, you might want to switch back to Java 11. Okay, but for now we stick to this one. Let's open this file. So open graph file, or use it over here. We go into apps, reverse me challenge, Callgraph, and we select this file and then hit the OK button. Going to maximize this real quick. Okay, afterwards. Now we can see we've got 28,000 nodes and 58,000 edges. So these are functions, and displaying them will be ridiculous. Let's see how good is Gephi doing this. We can see it's slowly loading, but now it's finished. Nice. So we've got this big blob over here, and every single dot is a single function call. We can now apply different layouts to handle this a little bit better. And we can find them over here. So if we choose a different layout, for example, this one over here, and we click run, then Gephi is trying to expand this to the view which we have seen on the documentation. But I'm going to stop this because even if Gephi is able to display all this information, we are not able to handle them easily. Therefore, let's filter out in just the information we are interested in. So to filter this, we go into the data laboratory over here. And within the label, we can see this class names and also underneath the arrow, the function name. We are not interested in the Android support v4 and other packages. We are just interested in our package. Therefore, we use this filter. We click onto label and then we provide com.apphacking.reverse_me. It's a regular expression and therefore we do not have to provide those slashes over here. And these are now all function calls within our application. It looks way more clean, right? Okay, let's extract them. I click with the left mouse button onto one and I select this. I hit Ctrl A to select all of them, and then I click right mouse button, and then we say, let's see, move to new workspace. This is the easiest way for me to extract them from the other versions over here, or the other function calls. We have now created a new workspace, so we can close the workspace 1, the old ones. Yes. And now if we go back to the overview, nice. This looks way better than the previous approach. So we have limited those edges and function nodes only to our package name, which is way more clean than the approach before. Okay, so let's figure out how we can display these information. So by browsing over one, we can see, only the single function point gets highlighted. If we want to get the reference to this one, we can enable this by hitting this button over here, show edge. And now we can see those lines. And if we hover over one, we can see, okay, this one is calling those three or vice versa. We will figure it out how to read this later on. I'm also going to enable this one because if we highlight one color later on, these function points are also going to be highlighted, also those lines. We've got some single dots which are not going to be referenced in here. So what is this function called over here? That seems not to be called. We can enable the label for this with the text button over here. And now this hasn't become more clean, right? Yes, but we can adjust this label. So by expanding it over here, we go into labels and then we can select the font size and also, yeah, the color and things like this. I go on a font size 12. Okay, this looks more clean back again. Let's figure out what this single dot is here. And if you do not have the drag menu, you have to select it over here. And then you can drag and drop those points. We can see this one is regarding to the R class, the init. So we are not going to call this constructor for this class, but of course it's available. And therefore it's not referenced or has some edge nodes over here because we are not calling this function, but it did get called in the Android system itself. Therefore we have those single dots which here seems to be not called anymore. Okay, with the right mouse button you can navigate around. So yeah, finding our flag method over here, it's like find Voldo in a really huge picture. And I guess that's also not the approach we want to take. Let's mark our flag function that we can find this more easily. We go back into the data laboratory, we search for label and then for the flag method. And we can see, unfortunately, the results hasn't really been reduced because we've got this flags parameter in all those functions over there. We have to do a different approach. Therefore, we search for 1 because this is the class name that contains this method. And here we can see we only focus on the part after this arrow. So here we have the method flag, move on, init, distraction, and 1 compare. I do a left mouse click on the flag over here and then a right mouse click and I say edit node. And now we can adjust some layout for this node point. I do a color change, therefore I click onto this, I select green and then I drag also this button over here, which is I guess some alpha value for this color. Let's see. Yeah, it got some more values over here. Okay, but now if we click OK, we can see this flag has now been set to green. Let's go back and find our Voldo over there. Zoom out a little bit and here we can see, yes, it's good to see this one over here. Nice, we've got our flag method and we can now also see which functions are referencing to this. We can now start dragging out those functions, but yeah, this is not a nice approach. Therefore we use a filter or a layout. We select this one, this Rheingold. This is pretty good for our task. Then we hit run and now we can see the layout changes. I guess we can hit stop because it's already done. You also have some other, for example, for expansion, then you are going to expand this whole graph. It's more like a zoom in and also contraction and other stuff. So feel free to play around with the layouts. In my case, yeah, I think this one is really good for our task. Okay, let's filter this a little bit more manually right now. So our function calls are now stacked together over here and we can select all of them. Let me figure out this one does not contain our block. Okay, we are now dragging them a little bit together. In this way. And we are using this cursor over here and we say configure the size of this cursor to, let's say 80. Can be a little bit bigger. 120. Yes, and now we can simply, oh sorry, we have to stick to the hand. And now we can simply click and drag this block out. All right, we have isolated our function call graph regarding to our flag method from all the rest. Nice. Now I do some manual adjustment over there that we get a nicer overview. I'm going to speed this process up a little bit. Therefore I switch back the size of this cursor and now I'm going to do this. All right, here we have now our final overview about our function call graph. Let's figure it out how we can reach this flag method. So we start over here. And yeah, here we have to look very careful because here we can see if we zoom in, this arrow is pointing into our flag direction, and this green arrow is pointing away from our flag method. Therefore, we need to follow the left approach because we want to reach our flag method. Okay, let's see what we have to call. Within this one, we have to call this one, 4 move on. And this one needs to call 3 move on. And this one needs to call 2 move on, 1 move on. And here we are at our check, which is our entry point. Okay, now we have traced this back. Let's figure it out how we can reach this from the beginning. All right, we've got our check method, and this one calls 1 move on. We can see this in the arrow over here. Now we've got our first branch over here. So this method makes a decision, and we end up in this one over here, 2 move on, or we end up in 5 final value. And if we end up in 5 final value, we are out because we cannot reach our method on top anymore because there's no reference to this one. This one is going from here to there, but it's not going to be backwards. You can also see this if you hover this. We only have this line at the bottom. At this point, we already know, okay, we have to make this check that we definitely go into 2 move on. From there on, we've only got one direction into 3 move on, 4 move on, and here we have our next branch. And this one is also really important because this one makes now the final decision if we go into our check over here, our flag check, or if we end up at this one, 5 move on. But this one is a dead end. So if we go this direction, we lose. If we go right, we win. That's easy. And yeah, this is the approach on how to create and handle a call graph. Let's assume I wouldn't have named this that nice for you. So there isn't a method 1, 2, 3, and 4. So these methods are named A, B, AB, ABC, and so on. You would go crazy if you stare at this code and try to figure out which direction ends up in the final flag check over here. And maybe the flag check isn't named as flag and things like this. So you can try to do this approach manually. It's also not that big of a flow graph over here. But imagine you would have go through 30 or 40 function calls to finally reach your point. I guess this is the best approach, at least in my opinion, to solve this task. Feel free to solve this challenge. I'm not going to spoiler this, and yeah, if you have questions regarding to the solution of this, please write me a message. Alrighty, in the next section we take a look at the real world Android capture the flag, and this one was pretty hard. So showing this approach on a challenge like this really points out the benefit of creating a call graph or a flow graph for an application that is obfuscated or made to be hard to reverse engineer. Feel free to play around with this furthermore, also with the settings, layout, color definition, and things like this. And yeah, after you have finished this, I'm looking forward to see you in the next section where we take a look at the real world capture the flag challenge. So I'm going to see you there.